Example, convert each angle to radians. Express each answer in exact simplified form and rounded to 2 decimal places. So let's consider part A, where we're given an angle of 225 degrees. The easiest way to convert degrees to radians and back is to use the fact that 180 degrees is equivalent to pi radians. So this is similar to how we would say something like, 1 yard is equal to 3 feet and do conversions that way. Okay, so let's go ahead and convert 225 degrees into radians. So I'm going to write that as 225 degrees, and I'm going to multiply it by a conversion factor, where my degrees are on the bottom because I want them to cancel out, and the number of radians I have are on the top. Now, often radians are left without writing radians, and it's assumed if we're talking about an angle, and I'm not using the degree symbol, that I'm talking about radians. So here I notice that my degrees are going to cancel and leave me with radians. Okay, and then I can just simplify. So just reducing this fraction, I get 5 pi over 4. So this is my angle in radians, and I can use my calculator to get the decimal approximation to 2 decimal places that it's asking for. I think I can delete my 1 yard is 3 feet down here. So I'm going to use the Desmos scientific calculator and just put in 5 pi divided by 4 to get that. And I get 3.93. So 3.93. And again, both of those are in radians. If it feels weird to leave it without a unit, you can certainly write in radians like that. Okay. Let's go the other way. So I have negative 140 degrees. I am going to leave that as a negative 140 degrees and then multiply my conversion factor. So same as part A here to start. And then I'm just going to reduce. I notice that my units cancel, which is what I want. And then I can divide both by 10, so negative 14 pi over 18. And then eventually, let's see, divide out of 2 leaves a 7, divide out of 2 leaves a 9. So I get negative 7 pi over 9. And notice that I have pulled the negative out front. And then this is equivalent to, okay, so if I want 7 pi divided by 9, so 2.44. So negative 2.44. And again, these are both in radians. This is what we would think of as exact simplified form here. And then down here is our approximate form to 2 decimal places. Now the other example is going to be going the other way. We are given these in radians, and we're going to convert each angle to degrees. We want to express exact where possible, and then round it to 2 decimal places where necessary. So in part A, I'm giving 2 pi over 3 radians, and I'm going to say that is equal to 2 pi over 3 times the conversion factor. Now I want this to become degrees, so I want 180 degrees in the top, and then I'm going to have pi radians in the bottom. I'm going to see if anything cancels here. So pi over pi, that's good. Let's see, that gives me 360 degrees over just the number 3, so I get 120 degrees. And this is exact, so I don't need to approximate to 2 decimal places. I can see that I'm given this angle 2 pi over 3 radians. Let's see if our answer here makes sense. Well, 2 pi is all the way around, so 2 pi over 3 is a third of the way around. 360 is all the way around, so 120 degrees is just a third of the way around. So I feel good about that answer. Part B is asking us to convert 2 radians into degrees, so just 2. So I'm going to do the same thing. I'm going to have 2 times my unit conversion factor. Again, I want to turn this into degrees, so I have the degrees on the top. I want to get rid of radians, so the radians are on the bottom. This just gives me 360 degrees over pi. That's about as good as I can get in terms of simplifying. So then I'm going to go to my approximation, and again, just using my calculator, 360 divided by 360 divided by pi, I get 114.59. And again, I'm using degrees there.